Can everybody see my screen? Can you guys? Yes, you can. Okay, great. This is Iolite 4. So this is like the full version of Iolite where you can do lots of different types of data reduction, anything from simple baseline subtraction and quantification to more advanced data reduction, such as like imaging or uranium-lead geochronology. This is the big version of Iolite, so you can do pretty much everything. For the first part of this, I'm going to do just basic data reduction, so just quantification, bulk analysis. And the way this works is there are tabs here we have on the top and then along the side, and you sort of just work left to right on the top and top to bottom on the side. So this is a new session of Iolite. So we're just going to hit new session. Okay. And the first thing we want to do is import the data file. And so for this, it's going to be, let's see here. This Gabbro data here. This is going to be like our ICP-MS output file. So Gabbro data.csv, open. And you'll get a notification down here that says it imported. This is from an Agilent. So this is an Agilent data file. And then once we have this data from the ICP-MS imported, we want to import the log file, which is generated by the laser. The log file from the laser has the position of the laser and time. So laser log, actually it's this one. So Gabbro log, open, okay. And so seeing here, this green is the timestamp for the log file generated by the laser. And the blue is the signal from the ICP-MS. And we want to make sure these are aligned. So you can hit auto sync. And that usually lines them up pretty well. But if it doesn't, like right now, we can just drag, hold shift to drag these two together. This. And so we can see the green, which is the laser firing, is aligned with the blue, which is the signal from the ICP-MS. The beginning here, you can see is NIST 612 glass, BCR. These are the different sample types. So once this is all aligned, hit done. And after that, we're going to move next to samples. So this shows all of our different samples that we ran with the names. In order to have these names here, they need to be named in the laser software. And then that will hold the names with that log file that we just imported. So it just makes data reduction quite a bit easier. And so from here, we're going to make what we call selections. Selections is kind of another way of saying peak integration. So we're basically taking this data and giving it a name. And so we'll go through and see NIST 612 here. I'm actually going to search up here so I can pull up just the NIST 612, which I'm doing in the top right here. So now you see, now down here, it's just all the NIST 612. I'm going to select all of these. And now we're going to give it that name. So create selection. Iolite has a lot of these reference materials already saved in it automatically. So it recognizes this as NIST 612. If you have a reference material that is not saved in Iolite, it's really easy to create a new one in the tab reference materials. And you just type in all of your values. So you can enter in any standard in here. But it has a lot of geological standards already. So back to here, going to create a selection for NIST 612, which it already recognizes here. And if we want, we can crop off the beginning, crop off the end, set a duration, just to kind of define what part of that signal we want to take. So I'm going to do it right now with no cropping. And then we can go check how that aligns. So if we go into the time series over here, this next tab down on the left, we can select an element and plot it. And these little controls up here on the right, there's two hands you can use to drag. If you only have one selected, then it'll only go in the x-axis. If you have the other selected, you can move in the y-axis. You can also use the scroller on your mouse. And then to zoom in, same, you can do X and Y, or just X, or just Y. And down below, it shows a view of the entire experiment or all the data that's loaded in. And we can drag down here to view as well. And if at any point we get sort of lost, you can just double click down here. And that brings it back into zoomed out. So that selection we just made is for NIST 612. And so if we select NIST 612, you can see that that black bar is the selection you made. And it looks like it lines up pretty well with the data. So there wasn't any cropping needed here. But if we want to, we can crop off the end, crop off the beginning. We can set a duration to make sure that this selection or this peak integration fits the data perfectly. So now we'll go back in and do the rest of our data. So it looks like the next standard is BCR. Same thing, select all of the BCR, create selection. And again, Iolite recognizes BCR. So okay. Do the same with BHVO. So now we have all of our reference materials selected. So after that, we're going to select our unknowns. So this OPAC is our unknown. And so it doesn't recognize that as a standard, so we're going to call it whatever we want. So OPAC unknown. Okay. The next one is PLAG, which is a plagioclase. Unknown. Okay. And I think we have an olivine. So live. Okay. So now, if we go back into the time series, we can see we have selections for these 3 reference materials, as well as our 3 unknowns. A lot of different elements here. We'll go with magnesium. Yep, so the 3 unknowns, 3 reference materials. And so the next thing we need for the data reduction is a baseline so that we can do a baseline subtraction. So for that, I'm going to select everything. Create selection from sample. And for star crop, I'm actually going to go -5. So we're not taking the actual part where we have data. We're going to take what we call a gas blank. And this is when the laser is warming up, but it's not firing the sample. And we have to call this a baseline group. Okay. Back in time series, we see our baseline group. And that does not look the way we want it to do. It looks like it's on the samples. And it's because I hit -10, but still included everything. So I'm going to go back in and create it again. Oops, I wrote over the NIST 612. Accidentally called it NIST. So baseline, let's do a -20 this time, and we're going to do it for a duration of 15 seconds. And then baseline group, and then replace our current existing baseline because that last one didn't look correct. So, okay. That looks better. Now the baseline is where it needs to be. It's not overlapping with any data. You can see it's all the way along the bottom here. So now when we do the baseline subtraction, it's going to take any of the actual signal and subtract it. In this window, you can sort everything by name, by start time, end time, duration, and so on. So moving left to right again on top, we're going to go to channels. So channels refers to all of the elements that we're looking at. And within channels, there are 3 types of channels. So we have input, and that's going to be just raw data, which means that it's the data the way it was imported. Nothing has been done to it yet. No baseline subtraction, no quantification. It's just the raw counts imported by the ICP-MS. Once we run blank subtraction, then we'll have intermediate, and it'll be these same elements, but it'll subtract whatever this baseline value is down here. So if you have a sample like silica or something that has a really high baseline, it'll subtract that from the actual data. And the baseline subtracted data will go in intermediate for all of these elements. And then once we run full quantification and we get concentration, concentration will fall into the output tab. If we want to view the selections that we made, just what we did a little bit ago, we made selections for baselines. We have 96 of them. We made reference material. We have 3 of them, the BCR, BHVO, and NIST 612. And we have unknowns, the OPAC, pledge, and the olivine. And then the next one over is reference materials, which is just a library of all the reference materials you have. You can add new reference materials, you can delete them, but this is just a reference material library. And once they're saved, these will stay in here and they won't go anywhere. So you can open a new session and all the same reference materials will be in here as long as they're saved. So now we'll start moving over here to the left, down to time series where we were just in. And in here, we can kind of look at all the different elements and sort of just visualize the signal. Right now, we're plotting magnesium. You can plot silica, give them the same y-axis. There we go. So we see the background is a little bit higher for silica. The baseline looks like it's about 400,000 counts per second for silica, which makes sense. That's a difficult element for backgrounds. Thorium, uranium, and so on. So this is just really good for visualizing your data. And once we have all of our selections made, they'll be down here on the left. So you see the baseline has a symbol of a downward arrow. The reference materials have a trophy cup. And the unknowns will have a target, like here. And if you find that maybe it doesn't line up, or you're getting some weird data that you don't want to be included in your selection, you can always shift and select and adjust this how you want. And right now we're using the Spline Auto Smooth here to track the data through the experiment. It also tracks the baseline. So we can see it's not perfectly flat. There's a little bit of fluctuation. So we can change this if you want. The Spline Auto Smooth is a very good one that works. But if you didn't want it to be so dramatic, let's see here. Then we could do a different smooth 1, smooth 7, smooth 10. You can do a mean fit. It's just flat through the mean, linear fit, and so on. Whichever fit gives you the most representative data. And once this is done, we go into data reduction. And these are all the different types of data reduction you can run. 3D trace elements. Here is the sort of most advanced trace elements quantification. You can also just do a basic baseline subtract, or if you want to do hafnium isotopes, uranium, lead, and so on, you can do all of that. So for this, we're just going to do basic trace elements quantification. So for this first window here, we're going to set our external standards. And we used, let's see here, NIST 612, BCR, and BHVO. Well, all right. And so this allows you to visualize not just concentration and intensity, but also any drift over time. So you can see in time, it drifted up a little bit in sensitivity. So that's why we see the drift up. And we also can see intensity on the y-axis and concentration on the x-axis. From there, we can look at our calibration curves and blocks. So we see the X here is NIST 612. The plus sign is the BCR2G. And this little yellow dot down here is BHVO. So got a pretty decent calibration curve, 0.997 for the R squared. And then you have the option of using an internal standard if you like. I don't have any for this one, but if you had an internal standard, you would leave this checked and you put in the element of your internal standard, the value, and the units. But I'm going to uncheck it for this because I don't have an internal standard for these. So this is going to go unchecked. And we just hit crunch data down here on the left. You can see this wheel on the right. It's working on crunching the data. It looks like it is finished. So now, if we go back to our data and go to selections, or I'm sorry, channels, now we have the input, which is the only thing we had before with the raw data. We have intermediate, which it calls counts per second, which is the baseline subtracted only. This also includes the slope and your intercept. And we also have output data, which is in concentration, and in this case, ppm. So if we go into results, and we can plot any one of these and see all of our individual. So for each one of these, it looks like there are 9 scans for each. So this shows all of our concentration, or I'm sorry, I need to select concentration. We'll go magnesium, ppm. So here's our magnesium for BCR2G, every single line. For BHVO, each line with error also, and then the NIST 612. And that's really all there is for data reduction. We can go and do a data table now where it shows everything in like a spreadsheet view. First, where it just says the element is the input. If we scroll over, we see counts per second, which is baseline subtracted signal intensity. And then scroll all the way over ppm. And then from that, you can export to file. It's this next tab down. Statistics, Excel. You can choose which selections you want. So if we want to select just the 3 unknowns. And then for channels, we want the output. So we want all the outputs. So we'll go to just all outputs. And I want the mean and maybe 2 standard deviation. Hit export. Call it training data. Open the file. And now we have all of our data in concentrations. So here's the mean, standard deviation. Sodium is coming up negative for some because it looks like the background was higher than our actual signal. But for like magnesium and titanium, iron, we have all positive numbers. And this is for the opaque unknown. And then each single line scan, for the plagioclase, and for the olivine, and we have both mean and standard deviation. And so that's all for data reduction. Are there any questions at this point?
Very question. The standard, the reference material in database, the Iolite
I'm sorry, what's
with
that?
the database.
Yes, one sec.
I insert the reference material in Iolite.
I'm sorry, I don't understand.
Roberto, ¿me puede ayudar?
Sí,
No,
sí,
Roberto.
sí, dime.
Roberto, mira, la consulta es si el Iolite viene con la base de datos o yo puedo ingresar materiales de referencia.
Si tú puedes ingresar un material de referencia ahí,
Claro, o
de
sea,
forma manual
o el
desde
Iolite
algún
viene
archivo.
claro, el Iolite viene con una base de datos de materiales de referencia o yo tengo que ingresar los materiales de referencia.
Ya. Ya, porque inicialmente él lo que hizo fue traspasar un dato que generó desde el CPMS. Y se lo trajo para acá y lo empezó a procesar.
Claro, pero, por ejemplo, claro, él procesa la señal, pero si tengo un material de referencia para compararlo, tengo que tener el valor. Entonces, en algún punto, yo tengo en la base de datos, está el valor versus la señal. ¿Cachai? Del material de referencia. Entonces, a eso voy yo, po. No sé si me entiende. Porque él en la base de datos acá tiene el valor del material de referencia con la señal. ¿Cachai? Entonces, eso ¿cómo lo hace? O sea, ¿cómo le mete el valor? Porque si yo solamente recojo la señal, lo que hicimos la vez pasada, yo recojo la señal, en ningún caso en el ICP yo coloqué los valores del material de referencia.
Ya. Entonces tú quieres saber si esta base de datos está bien incluida en el software o tú tienes que ingresarla de
Claro,
forma manual, digamos.
los valores, material de referencia por material de referencia y por cada elemento.
Hello, Ross.
Yes.
The customer is asking about is the software has the database of the reference materials or
Yes. So Iolite comes with all of this. And is the customer familiar with GeoRem website for data for reference materials?
I'll ask them. Hold on.
Okay.
O sea, viene con el material, pues lo tengo que buscar de ahí de GeoRem.
Claro.
Ya, y si hay alguno que, por ejemplo, hay gente que hace su propio material de referencia y yo lo puedo ingresar como New Empty Ref Material. El primero.
Pero no, después
Mauricio, no te escuché bien.
No, te digo que si yo quiero ingresar un material de referencia, lo ingreso ahí donde tiene New Empty Ref Material. Ahí donde tiene el cursor, arriba.
Ah, ya.
Ahí tiene que ser. ¿Aló? ¿Me escucha?
Sí, sí, estamos aquí generando la consulta.
Ya, y la otra consulta es si yo hago por triplicado el estándar y quiero sacar un promedio del estándar, ¿eso me permite hacerlo también, el Iolite?
Ross, can
Yes.
the customer include the information of the reference materials in that part of the software, the screen that you're looking in the meeting?
Yes, this is standard.
Okay, this is the standard reference material, but can he make, can he create or edit any information that he wants?
Sorry, it's hard to hear you. The connection is not good. I'm going to type in the chat.
No puedo ver.
Hold on, let me. Iolite. Do you hear me good
Yes.
now, or it's okay? Well, we understood the point of the software has a database, but
Yes.
in case that the customer wants to include or
Uh-oh.
No,
Oh, no.
no. Wait.
sorry, Ross,
That's okay.
do you hear me?
Yes.
Okay, again, it's can the customer include or add an custom reference material that they want to include in the database?
Yes, it's very easy to do. I will show you.
Okay, great.
So there are two ways to do that. You can import from GeoRem. There's a large database online called GeoRem that has like everything you can think of. Also, if you want to do one that is not on GeoRem, you do new empty reference material. So new reference, and then you can add, you know,
Okay.
and so on. Yep, just like that.
Ah, perfect.
Ah, ya.
Okay.
Okay. Thank you.
¿Está claro, Mauricio?
Sí.
Maravilloso.
Y lo del triplicado, o sea, si yo analizo un estándar por triplicado para hacer el análisis de datos, ¿puedo sacar un promedio de ese triplicado de estándar? O el material de referencia, en este caso.
Ok, voy a poder hacer la traducción. Ross, can he make a triplicate analysis and get a summary? Hold on, I'm trying to find the right word. Hang on, please. Okay. Again, if he analyzes a triplicate for reference, can he get the average at the final analysis?
So for results,
Yeah, for results, right.
so here is the average.
Son los promedios, Mauricio. En teoría sí se puede tener
Sí.
un promedio triplicado.
Ya, sí lo vi.
And then exported, here are the average.
Exportarlo en Excel y obtener los promedios. Ah, ya, perfecto.
And if we want, we can export, let's see. Group means.
Perfect.
Okay.
Okay, interested.
Okay. Any other questions for this?
¿Alguna otra consulta, Mauricio?
No, estamos bien. Ok. Estamos bien.
It's okay for the on the end of the customer. So it's okay. And for our end, it's okay as well.
Okay. Well, this pretty much concludes how to do data reduction, and I can send a link for an online tutorial that's quite a bit longer, but goes into greater detail, doing the same things I did today, but with more explanation and example data for the customer. If you'd like me to email that.
Okay, great. Roberto can email you to ask requesting this link.
Okay. Is there anything else anyone would like to see for today?
Mauricio,
Estaremos
¿está
bien, sí.
está
Sí,
bien?
está bien. Sí, las dudas que tenía, y la última, sí, tengo una duda más. El blanco, ¿cómo lo hago?
Just the last question, Ross. The blank, how can you make it?
The blank?
Yeah.
Yeah. So you remember when earlier we made selections where we choose this and create selection. Then the blank, we just went negative because that's the warm-up time for the laser. So when the laser is warming up and not firing, and I call it the baseline here, baseline like blank.
Okay.
And then that comes up over here.
Ya, no, ok. En el fondo no es un blanco real, es un blanco de software.
Correcto. It's a software blank, right, Ross?
Yes.
not a real blank.
Yes. And so if the customer had like a real blank to ablate, like a sample with no elements in it, then you would do the same thing as these.
Okay.
So if we want to like say this is blank, 0, 0, baseline, then it works the same.
Ah, perfect.
Okay,
Perfect.
perfect.
Todo claro entonces, Mauricio.
Ya, ok.
Buenísimo.
Sí, súper. Muchas gracias.
It's all of our end, Russ. Thank you so much for your time.
Yes, of course. I will send the tutorial and the example data, the link
Perfect.
to that, and then let me know if there are any more questions.
Great. I'll tell to Roberto to email you requesting the link. Okay? Or we'll send it with the email.
Perfect. Thank you.
Okay? Oh, thank you.
Thank you, Ross.
Gracias, Mauricio.
Thank you, Ross. Gracias.
Muy bien.
Thank you, Ross.
Yes. Bye.